Welcome to another Codesys training video. In this video we want to take a look at the example project for RS232 communication. I'm using Codesys Service Pack 3.5 Service Pack 11 patch 4. The counterpart on the device would be Codesys Runtime 3.5.11.0. Okay, so let's take a look. First of all, we have an initialization function. This one will be called on the event prepare start. Here you see function to call init. And in this function, first of all, we will check if the console mode of the device is already set correctly. So just very quickly, by default, the RS232 port of Opus devices is used for the Linux console. This would be console mode 0. But you can also just disable this Linux console. This would be console mode 1. Or you can configure it to run on a USB to RS232 adapter. That would be console mode 2. That's why here it says if console mode either equals 0, which means console is on, or bigger than 2, I don't know, then it will set this variable frame ID to 0, otherwise it will set it to 1. And the second thing it does, if the product type, HMD, Health Management Daemon, product type equals 3 or 6, which means if it's either an Opus A3 or an Opus A6 generation 1, then it will set the variable port to syscom port 3. This has something to do with basically the COM port mapping in the operating system. It's different for generation 1 devices and generation 2, so Opus A6 G2 or Opus A8. And this project should run on all of these devices. So we had to make this setting in case it's running on a generation 1 device. If it's running on a generation 2 device, it will work fine as it is. Okay, so this will be executed first. So let's take a look at this configuration screen if the frame ID is set to 0. That would be this screen. It basically says what I have just explained to you. Let's see what it does. Oh, it does basically nothing. It's all in the main. So let's go back to main. Or maybe, sorry, we will have to go through the get key states function. The keys will all be cached here. So if I press either on this touch field or I use any of the soft keys, that will all go through here. And this is just again a differentiation between Opus A3 and A8, which both have 8 keys, and Opus A6 or A6 generation 2, which have 12 keys. So the first 4 keys are the same. They are on the left side, keys 1 to 4. Now for the A3 for the A8, they are on the right side, but they are just the first 4 keys, sorry. For the A3 and the A8, it continues with F5 to F8. For the A3 on the right side, for the A8, it just continues onwards. So that would be this setting. The project was designed with left key 1, 2, 3, 4 and right key 1, 2, 3, 4. So we are mapping the next 4 keys onto these variables. For the A6 and A6 generation 2, we would use the keys on the right side, but these are starting from F7 because the A6 and A6 generation 2, they have 6 soft keys on the left side. So on the right side it starts with F7. So we will map F7 to F10 to those variables for the A6 and A6 generation 2. Let's go back to main now. This function is executed, so we will always catch the pressing of the keys. And now let's see. We are sorting this by key. So if the left key variable has been set, then we are setting it back to false. And then we are checking, is the frame ID 1? So is it already configured that RS232 communication is possible or not? If not, this one sets the console mode to 0. Let's take a look back at the visualization. That's this key here. So if I press the left key 1 or touch this button, it will set the console mode to 0. Left key 2 will set it to 1, and left key 3 will set it to 2. After having set it to 1 or 2, because 0 is the normal setting, which means the Linux console is running on the port, and we cannot use it for communication. So we set it to 1 or 0, and then we have to restart the device. The console mode setting is a setting that is stored in the EEPROM of the Opus device, and it will only be checked at the start of the system. So this is not something that you can do on the fly. So once you have changed the setting, you need to restart. You cannot use the RS232 port while it was set on console mode 0. So we press the right key 1. Let's see how it works. Right key 1, frame ID is 0, so we are just calling the reboot function from the power management. One more thing, I said left key 1 is checked, so this means if left key 1 is true, it is set back to false. I don't know if you have checked or if you saw this strange entry here. So we are not writing this one. We are writing s equals, and what this means is it only sets this variable to 1. It only sets it, it doesn't reset it, so it doesn't set it back to 0 or false. I think they are, let me see, they are Boolean. Yes, they are Boolean. So it only sets the variable, but it doesn't reset it, because otherwise, if the soft keys of the Opus devices were used, left key would be set to true for one short moment in this with this scenario, but then it would go back to false because you only push the key for one moment. So it only sets it, but it doesn't reset it. And the resetting is always done here in the code. Okay, so we have set the console mode, for example, to 1. We have disabled it, and now we are restarting the device. Let's look at the init function again. If the console mode is between 1 and 2, it will set the frame ID to 1, and then we will see this wonderful screen. Let's make it a little bit bigger. Here we can basically change settings for the RS232 communication, and we can read messages that are active on the RS232, and we can send messages back. So this is a nice testing scenario to work with the terminal program. Anything you type in the terminal program and then you press here, you will see it here in the buffer field. And there is a preset test string right here. I think it's ABCDE 1, 2, 3, 4, 5. It's very creative. But in any way, whenever you press the right key 2, it will send this string out on the RS232. So let's take a look. First, we will go quickly through the settings. We have the baud rate. the data bits, the stop bits, and the parity. Let's see what happens on mouse click. Once again, it only sets left key 1 to true. So it's all back here in main. So we are here, left key 1. Okay, we set it back, and now we are at this point because now the frame ID is 1. And what happens is we have the baud rate selection. Let me see. Yes, the baud rate selection is just an integer value, and it will just be adding 1, and then it divides it. It uses mode 6 because we have an array of baud rates from 0 to 5, 6 entries. That's why mode 6. So it will go 0, 1, 2, 3, 4, 5, and then 6, and then it will go back to 0. And in this array, we have baud rates 4,800, 9,600, 19,200, 83,400, 57,600, and 150,200. This is the default baud rate for the Opus device. Okay, so that's the baud rate. Let's see, left key 2. That is for the number of data bits. Okay. Oh my, so this one looks nice. So I think we can set this in a certain range. I'm not exactly sure. I think it's from 8 to 10 data bits. Let me see. I can't tell you this right now. I'm not sure. Take a sheet of paper and figure it out for yourself. I'm sorry. Oh, and the last thing in all of these now, it sets the COM reset flag to true. This I forgot this when I was up here, so I'm telling you now. So after making this setting, it sets the COM reset flag to true. We will come to this a little bit later on. Now we have the number of stop bits. It will look very similar. Yes, another formula that I don't want to talk about now. And the left key 4 is the parity, which again, I think it toggles between no, parity, even, and odd. We can see it right here. Yeah. For parity and stop bits are very nice. We have arrays again. So we have 1 stop bit, 1.5 stop bits, or 2, and no, odd, or even parity. And this formula goes round and round between those settings. So you can press the keys again and again and again, and it will just toggle between all the possible settings. Okay, so we have set COM reset flag to true. And now, don't worry, there's a long list now. If COM reset flag equals true, then, and now it does all this. But most of that shouldn't worry you at all. First of all, we are setting back the COM reset flag, so this isn't executed more than once. First, we are closing any serial connection that we might have had before, because we need to shut down the connection, change the setting, and then build up the connection again. So you will see here we have the port, which directly uses our port setting from the init function right here. And let me see. One second. Port, there it is. So this is the default setting for generation 2 devices, so A6 generation 2 and Opus A8. There it will use COM port 1. And in case it's an Opus A3 or A6 generation 1, it will change the setting to COM port 3. In both settings, everything will work correctly for the particular device. So we are setting the port, the parity, the baud rate, the stop bit, The buffer size is set to 100 here. This can be changed as needed depending on how much data is coming through in your actual project later on. And all of these settings, they're just default. You can see most of it is set to 0. Here we have the data bits 0, 0, 0. And after all these settings are done, we will activate the connection to the COM port once again. So we shut down the COM port connection, apply all these settings, and then with these settings we start it back up. And then we can receive and send messages. Let's take a look. So we are pressing the right key 1. This is here. So we are reading a message from the RS232. How does it look? First, we're setting back the key. We're checking once again if we're on frame ID 1, so if our serial console can be used for communication. Now we are checking if there is a working handle to the COM port. If not, we do nothing. If it is, we will execute the command syscom read. So this is the actual reading from the RS232 port. You can see a little bit of documentation. So this is, of course, not coming from us. This is Codesys content. And the function takes the handle to the COM port. We have a buffer variable. That's a simple string variable. And it references, it wants the pointer to the buffer. You know what? Go to definition. Let's take a look. So we have the handle to the COM port, the pointer to the data buffer. I already said that. We have the requested number of bytes to read. So here we are saying that we are reading a maximum of 80 bytes. What else? Timeouts in milliseconds to read data from the device. 0 immediate return. Okay, if the timeout elapsed, the function returns with the still received data. Could be less than the requested number of bytes. Okay, so this is how much time we give to read these number of bytes. But since we have an internal buffer for the RS232, we are setting this to 0. Oh no, it's infinite. Okay, no, sorry, we're setting it to infinite. I thought we set some timeout to 0 down here. Timeout says no, wait. Anyway, you can just keep that as it is. The most important thing, where are we? Right here. The most important thing is, of course, the connection to the buffer. At the end, we have the result. It should hopefully always be 0. If there is anything wrong, you can analyze the COM result of this command. So now we have read a number of bytes into the buffer. Here we know how many it is. And here we have the actual string. Now let's see. Yes, this is very important. The RS232 is like a stream. There is no beginning and there is no end, right? So we are just taking up to 80 bytes from this stream, and we're saving it into a string, but the string doesn't have an end. So we are checking if we have received a correct amount of bytes, more than 0 and less than 81. And if we did, we're putting a 0 at the end. Mind you, this is not 0 with like this. It's not the string 0, it's the character 0, which signifies the end of a string. This is absolutely necessary for Codesys to be able to read this string. Otherwise, it will see the string with an infinite amount of bytes because it doesn't see the stop sign. This is like the stop sign for a string. So we are taking out a number of bytes from the buffer, depending on how much there is. And we are putting a stop sign at the end for Codesys to know this string ends here. Okay? Okay, so then this buffer will be displayed in this field. Very quick, very easy. Now the sending. So as I told you, we have a test string here, which consists of ABCDE 1, 2, 3, 4, 5. If you want to change that, you can change the variable here while you are connected. In your real project, of course, depending on what you want to transmit, this data would vary a little bit. So let's see how we are sending. If write key 2 and frame ID equals 1, then write key is set back to false. We're checking once again if we have the correct handle for the COM port. If we do, we are writing, we are using the command syscomWrite. We are giving the handle to the COM port, the address to our string that we want to transmit. Now we are giving the length of the string, so we are saying how many bytes we actually want to send, because it might not be everything in that string. Again, we have this timeout and we have the result. After that, we are writing again, and we are writing, let me see. Yes, we are sending a carriage return. So let's say you have a terminal program open, and you are sending this string ABCD loop. It would go on and on forever in the same line, and we don't want that. We want it, if we want to send once again, we want to send it in a new line. So we are sending the 2 characters for carriage return. The rest of the command is the same like up here, and that's it. That's the sending. To complete this, here you can set the console. It shouldn't say boot mode, it should say console mode, I think. Yes, if you press the right key 3 and you're in frame ID 1, set back the key and set the console mode back to 0. And then finally, we can reboot by again executing the power management daemon function reboot. So pressing these 2 keys will bring the device back to the normal state with the Linux console running on the RS232. Very important for us in the technical support, because when the next customer calls, we want to be able to use the console for debugging and checking and everything. So that's it for this project. You can get this from us. Contact us if you don't have it already. Have fun with it, and see you in the next video.